Hi everyone, in this video I'm going to show us how to do matrix multiplication in using NumPy and PyTorch in Python and in Google Colab. Now the matrix multiplication is a more involved way of doing the dot product. The one requirement is that the column of the first matrix and the row of the second matrix has to be the same. So like for example, if you have a 3 by 2 matrix, which is 3 row and 2 column of the first one, and you multiply that with 2 by 3 matrix, which is 2 row and 3 columns, that's allowable. Then your resulting matrix is 3 by 3. If you have, like for example, 3 by 2 times 3 by 2, that would not work because the 2 and 3 does not match, does not equal to one another. Now, if you take a look at the notebook right here, you see that the first thing I do, as always, is to import NumPy and the PyTorch library or Torch library right here. In the second cell right here, I'm creating a 3 by 2 matrix using the random integers of the NumPy library. The random integer method right here. What it does right here is that it'll pick a random number between 1 and 10. You can specify the lower and the upper, and then you can specify the shape that you want the matrix to be. In this situation, it's 3 by 2. The second example is also from 1 to 10, but 2 by 3. And the third one is 3 by 2. And I put this result into variable x, y, and z, matrix x, matrix y, and matrix z. And I printed out right here x, y, and z, as you can see. Now, if you run this thing again, every time you run it, it's going to give you a different number because it's going to draw randomly the number between 1 and 10 and put it here. Okay, so here's matrix x, matrix y, and matrix z. You can see right here is 3 rows, 2 columns, right? This one is 2 rows and 3 columns. And the third one, the z one, is similar to the x, which is 3 rows and 2 columns, 3 by 2. So to multiply, do matrix multiplication in NumPy, you have this function math MLU, which is a shorthand notation for matrix multiplication. And this one right here, I'm doing x and y. The order is the matter in this situation. If I do y and x, it'll give an error right here. Okay, so if I do matrix multiplication x and y, it's going to give us the result right here. And basically what it does is that it's going to go do a dot product of rows and columns. So for example, if you take a look at this one right here, right, number 24, which is the first row and second column. So what happened is that we'll take the first row. First row is of x, which is 5, 9 right here. And the second column is 3 and 1 right here. So if you do the dot product of that, this right here is 15. 3 times 5 times 3 is 15, and 9 times 1 is 9, right? And 9 plus 15 is 24. See right there, right? Now another example you can see is, let's do the second row and third column. So what you would do is that you take the second row of the first vector x right here, 1 and 3, and then the third column is 2 and 3. So 2 times 2 is 2, 3 times 3 is 9, right? And add them together as a dot product is 11. And you do it element by element right there, and then you would get the result of 3 by 3. So you can see right here, right? If you have a 2 by 3 matrix and you multiply a 3 by 2 matrix x, and when you multiply that with 2 by 3, 2 and 2 would match right there, right? The resultant vector, the final vector, is this right here, the row of the first matrix and the column of second matrix, which is in this situation is going to be 3 by 3. So if this thing right here is 2 by 3, for example, and multiply by 2 by 4, what you have is 3 by 4 matrix as a resultant matrix. Another way to do matrix multiplication, which is this is a shorthand notation. You can do this add symbol right here. Instead of writing this, you can say x add y, and you can see right there, right? It will also give us the same result right here. if you take a look at this cell right here, you see that I have a 3 by 2, and I'm multiplied with a 3 by 2 right here, right? And when I do that, Colab or Python or NumPy would give us an error saying that the size different, 3 is different from 2, right? So you have to have this number, it's either going to be 2, 2, or 3, 3. Then that matrix multiplication would work. Otherwise, if you have a size mismatch, it's going to give us an error, as you can see right here. Now, there's another way to multiply in NumPy, and you do this by element. And the one requirement is that the shape has to be the same. In this situation, the shape has to be the same. So x and z in this situation are both 3 by 2. And what we do in this type of multiplication is that we multiply element by element wise. So let's say, for example, if you look at 30 and 45 right here, right, or 30 and 3, okay? So go back to the original matrix. What you do is that element wise, so you take first and first, which is 5, and 6 right here, which is 30 right there, right? And 9 and 5 is 45. So right there, right? So 30, 45. So you go element by element, and you multiply that together, and just put the result where the position is. Okay, and you can see right here, right? If I try to do the multiply element wise with different shape, it gives us an error right here. Okay. Now finally, we can also do matrix multiplication using the PyTorch library. So I can create a tensor 3 by 2 right here, and you notice that in this time right here, right, I'm using a random generator. So it's going to generate real number randomly right here. Okay, and the first one is 3 by 2. The second one is 2 by 3. Now in this situation right here, I also going to create a random number, but using NumPy 2 by 3. The reason is because I want to show us that if you have one matrix defined as using NumPy, and the other matrix defined using PyTorch, Python is flexible enough that it will let you do matrix multiplication between two different types right here. Okay, so you can see right here, right, the first one is that doing the x and y matrix multiplication of the same type tensor right here, and it gives us this result right here. Okay, and then this route right here is just gonna route it to 3 digit 1, 2, and 3 right here. So if you put 2 in this route right here, it's gonna route it to about 0.26 instead of 0.256 right here. You know, just this thing right here just makes things display a little bit better. And you can see right here, right, in the second calculation right here, I'm taking x and I multiply, which is the type tensor, and I multiply with, I'm gonna do matrix multiplication with z1, z sub 1, and then underscore 1, and you see that it has a type of NumPy array, but the matrix multiplication still go through. And the third example is that we can take the NumPy, convert it to tensor, and then give it a type float right there, right? And then we do the multiplication of x and z underscore 2, x and z underscore 2, and of course, right, both of these give us the same result right here. So these are some example of matrix multiplication in NumPy and PyTorch right here. I hope that it will help you understand it a little bit. Have a good day, and I'll see us next time. Bye-bye.